Imagine waking up in a place where the sunrise isn't just a daily occurrence, but a spectacle that unfolds every 90 minutes. A place where the stars aren't just overhead, they're all around you. A glittering tapestry stretching in every direction. Sounds like a scene from a science fiction movie, right? But what if living among the stars was closer to reality than we ever imagined? Welcome back to Space. Today, we're embarking on an incredible journey to explore what it would take to design space habitats, the future homes that could one day float among the stars. So grab a seat and get comfortable, because this adventure is going to be truly out of this world. For as long as we've gazed up at the night sky, humanity has dreamed of venturing beyond our tiny blue planet. But dreaming is one thing, making it a reality is another. So, how close are we to actually building homes in space? And what would life be like living off Earth? Let's start by understanding what a space habitat actually is. In simple terms, it's a man-made environment located in outer space, designed for humans to live and work in for extended periods. Think of it as an artificial planet or a colossal spacecraft that's more like a city than a ship. But designing such a habitat isn't just about constructing walls and roofs. It's about creating a self-sustaining ecosystem that can support human life far from Earth. One of the most significant hurdles we face is gravity, or rather, the lack of it. On Earth, gravity is the invisible force that keeps us grounded, literally and figuratively. It affects everything from how we move to how our bodies function. In the microgravity environment of space, astronauts experience muscle atrophy, bone density loss, and other health issues over time. So, to make long-term space living viable, we need to simulate gravity. But how? Well, imagine you're on a merry-go-round. As it spins faster, you feel yourself being pushed outward against the seat. This sensation is due to centrifugal force, and we can use this principle to create artificial gravity in space habitats. Engineers have proposed designs like the Stanford Torus, a giant donut-shaped structure that spins to create gravity along its outer ring. Or the O'Neill cylinder, which consists of two counter-rotating cylinders providing gravity on their inner surfaces. These concepts might sound like science fiction, but they're grounded in real physics and engineering. Building such enormous structures brings up another challenge: materials and construction. Transporting all the necessary building materials from Earth into space would be astronomically expensive and logistically complex. That's where the idea of in situ resource utilization comes into play. Instead of bringing everything from Earth, what if we could use materials already available in space? The Moon, for instance, has abundant supplies of regolith, a type of lunar soil that could be used in 3D printing processes to build structures. Asteroids are rich in metals like iron and nickel, which could be mined and utilized. Using space resources isn't just efficient, it's essential for large-scale construction beyond Earth. Now let's talk about life support systems, the heart and lungs of any space habitat. We need to recreate Earth's delicate balance of oxygen, carbon dioxide, water, and nutrients to keep humans alive. This means developing closed-loop systems that recycle air and water, much like Earth does naturally. For example, plants could play a crucial role as they absorb carbon dioxide and release oxygen while also providing fresh food. It's like having your own personal garden, but in space. Temperature control is another critical aspect. Space is an extreme environment where temperatures can swing from boiling hot to freezing cold depending on exposure to the sun. Insulation, reflective materials, and thermal regulation systems are essential to maintain a livable environment inside the habitat. Energy needs are immense, but fortunately, space offers a bountiful supply: solar energy. Without Earth's atmosphere to filter out sunlight, solar panels can operate at maximum efficiency. Massive arrays of solar panels could provide the necessary power for all the habitat systems, from lighting and heating to life support and communication. Speaking of communication, staying connected with Earth is vital, not just for personal reasons like talking to loved ones, but also for receiving updates, scientific data exchange, and emergency support if needed. Advances in satellite technology and potential quantum communication could make these connections faster and more reliable. Now imagine the day-to-day life in a space habitat. It's not just about survival, it's about living. There would be jobs to do, education for children, entertainment and community events. Picture sports adapted to low-gravity environments or art inspired by the view of galaxies outside your window. The social and psychological aspects of living in space are just as important as the technical ones. After all, we're social creatures who thrive on interaction and shared experiences. But perhaps the biggest question is, why? Why should we invest in designing space habitats? The answers are numerous and compelling. Expanding into space could help us access new resources, alleviate the pressures of population growth on Earth, and ensure the long-term survival of humanity. Moreover, the pursuit itself drives innovation and inspires generations to dream bigger. By the way, if you're as fascinated by the possibilities of life among the stars as I am, make sure to give this video a thumbs up and subscribe to Space. Together, we'll keep exploring these incredible frontiers. Now, you might be thinking, this all sounds amazing, but is any of it actually happening? The answer is yes, and progress is being made as we speak. Organizations like NASA are planning the Artemis program, aiming to establish a sustainable human presence on the moon by the end of this decade. Private companies like SpaceX are working on missions to Mars with the goal of making life multiplanetary. These initiatives are the stepping stones toward larger, more permanent habitats. In addition, researchers are experimenting with biospheres, closed ecological systems that can support life independently of Earth's environment. The Biosphere 2 project in Arizona, for example, provided valuable insights into how humans might live in self-contained habitats. These experiments help us understand the challenges of creating a balanced ecosystem where plants, animals, and humans coexist in a stable environment. Let's not forget the International Space Station, which has been continuously inhabited for over 2 decades. It serves as a real-life laboratory for understanding how humans can live and work in space for extended periods. The lessons learned from the ISS are critical for designing future habitats. From studying the effects of microgravity on the human body to testing life support systems, we're gathering invaluable data every day. So what does all this mean for you and me? Well, perhaps our generation or the next will witness the first communities living beyond Earth. It's a thrilling thought, isn't it? The idea that humanity could become a spacefaring species, exploring and inhabiting other worlds. Now, I have a question for you. If given the chance, would you live in a space habitat? Imagine the adventure, the challenges, and the unparalleled views. Share your thoughts in the comments below. I can't wait to hear what you think. As we come to the end of our journey today, let's reflect on the incredible possibilities that lie ahead. Designing space habitats isn't just a technical challenge, it's a grand human endeavor that combines science, engineering, psychology, and a dash of courage. It's about pushing the boundaries of what's possible and redefining our place in the universe. So next time you gaze up at the night sky, remember that those stars might not just be distant suns, they could be future destinations. And who knows, maybe one day we'll be the ones living among them. Thank you for joining me on this exciting exploration. If you've enjoyed this adventure and want to be part of more journeys through the cosmos, be sure to subscribe to Space. There's a universe of topics waiting to be discovered, and I wouldn't want you to miss out. Until next time, keep reaching for the stars and never stop exploring.